Hello everybody and welcome to our webinar today. We are going to talk and show the newest features of our measurement software, Oxygen. But before we start, I would like to explain some organizational things. On your right side of the webinar tool, there is a chat. This chat is used to ask questions. Those questions are anonymous and only me and my colleague are able to see those questions. So please feel free to ask us questions during the webinar. We are going to answer those questions at the end of the webinar. There is also a PDF, a handout available for download during this webinar regarding our oxygen measurement software. So let's start. Today, I'm going to be your moderator. My name is Ivica Baresic and I'm sales and business developer for Austria. And I'm joined today by my colleague, Raphael Ludwig, who is know-how expert and application engineer at Decoding. Hello, Raphael.
Hi.
It's a pleasure to have you here today in this show. And do you want to say something about yourself?
Yes. Hi. Welcome also from my side. Also, thank you, Ivica, for hosting this webinar today. My name is Raphael. I'm an application engineer of Decoding, and I'm going to show you some new features of Oxygen which were implemented within the last releases.
Perfect. Thank you for that. And what I would like to mention about you is that you, as an application engineer, you work very closely to our customers. And as a part of our product team here within Decoding, you work together with our R&D, software and hardware part as well. And therefore, the feature requests from our customers are getting pretty fast to our R&D, where we decide if we are going to implement those features and further on. So yes, we are going to talk about the features that landed in our Oxygen like a couple of weeks ago and a couple of days ago as well. And if you're ready, Raphael, I would like to start.
Absolutely, let's start.
Perfect. So I read through the changelogs and the first thing I found was some additional features regarding data recording.
Correct. So I would like to show you two new features regarding the data recording. Therefore, I just quickly opened the system settings on my software instance, which is open here. The first thing we did is to enhance the functionalities of the so-called multi-file recording. As a short introduction, multi-file recording means that you are able to split the data of one single measurement into different data files. The possibility to split them after a defined instant of time, for example, after 10 seconds to start a new data file after 10 seconds was already implemented a couple of years ago to Oxygen. Also, the possibility to split up the data into different data files according to a trigger event in case of event-based recording was also added to the software a couple of years ago. The new thing here is now the so-called split by absolute time option, which enables you to split your data of one and the same recording into different data files, and you can define this split time according to an absolute instant of time. This feature was implemented for one of our major customers who does long-term data monitoring over several days or also over several weeks. And his requirement was the following, that he wanted to have one separate data file for each day of the recording. And so he had the request to start a new data file every midnight of the new day. And something like this is possible with this multi-file split by absolute time. And additionally, what you can also see here is this new slider, which is named Ask for File Name Before Recording Start. With this possibility and option enabled, you will get a pop-up menu to define a data file name directly after pressing the record button. This was just to avoid, or because it was sometimes forgotten, that you have to define the file name before the recording starts here in this menu. And so you can just press the record button and then you have the notice, okay, don't forget to name the data file accordingly and correctly according to your measurement. Yeah, that's so much for the new and advanced recording options which were implemented.
Okay, perfect. And there's one more thing, something like auto recording that I did read.
Correct, yes. There was a recent requirement that the measurement device or the measurement system in general should start with the data recording automatically after the system has powered on. This consists of 3 different subtasks or routines to do this, more or less. The first one is that the measurement device is automatically started after it is powered. This possibility is given by every Devotron measurement device. So you plug it to the power supply and then the system will start up automatically. The second thing is that oxygen starts automatically after Windows has loaded. This can be done via the auto start menu of Windows. There you just add the oxygen executable into the auto start option, and then oxygen will start automatically after Windows has loaded. And now the new thing here to also start the measurement automatically without any interaction by the user is the following, that you have the possibility to start the measurement automatically. And this option can be found in the trigger and in the recording settings. So this option allows Oxygen to start the data recording automatically after the software has loaded. And so you can force the measurement device to start the measurement automatically without any interaction by the user when the system has powered on.
Perfect. So to recap once more, just turn on the hardware of the measurement hardware of Devotron and everything afterwards. So starting Windows, of course, starting the measurement software, of course, and also triggering or arming the measurement software happens automatically without. So it starts a predefined measurement setup, and you're ready to go without pushing any buttons. Perfect.
Exactly.
Perfect. Okay, so some improvements regarding recording. And yeah, let's go over to the measurement part. And I read something about reference curve.
Yes, there was a recent requirement and also frequently asked the question, is it somehow possible to have some reference curves and some reference values in time domain in a recorder to see if, and to have a hint if the measurement signal itself exceeds a certain threshold, for example. And this is called reference curves in our measurement engineer language, more or less. Therefore, we have a new possibility in the software. There are no reference curves directly implemented, but you can use a variable which includes the measurement time since recording start. I have it here on my screen, and when I start the recording, the measurement time starts automatically to increase. So this counts the time since recording start. It has ever been in the software here on this orange cursor, and now you can also use this time as a variable in the math menu. And using this variable in the math menu in combination with a table scaling enables you to simulate and to create some reference curves in time domain. I just have to say in this table scaling menu, okay, from second 0 to second 5, for example, my reference value will be 0.5, as you see it also here with the red curve. And then after 5 seconds, for example, the reference value shall increase to 10. And after 10 seconds, the reference value shall decrease again to a certain fixed value. Just to show you this, when I start the recording, my reference curve here will stay constant, and the white signal is my measurement signal. After 5 seconds, the reference curve increases to 1, and then it decreases again. And you can also set up some alarm here, some indicators, which clearly mark you the instant of time and clearly show you when this threshold of the reference curve was exceeded. So the measurement time as a variable in combination with the table scaling can or allows the engineer to set up some time reference curves.
This was now a live demonstration. You're using some kind of measurement signal here now to generate live while
Exactly.
showing?
That's just a simple tuning fork. And here you have a strain gauge sensor applied. And when I press the tuning fork, you see the signal increasing. And when I bend it, you see the negative signal And now you see the 440 hertz of the tuning fork bending in time domain. Exactly.
Okay. Perfect. Perfect. So this is a live demonstration. Very nice.
Sure.
Yeah. Let's continue with the next feature. That would be a sensor database.
Exactly, yes. We had also this requirement a couple of times that there shall be some possibility to store the certain settings of different sensors in a so-called database, that all the scaling information and the input setup configuration does not have to be done manually again and again when creating a new setup, but that the settings are applied automatically to the channel when creating a new setup. That's called the so-called sensor database. You can find this one here in the system settings when you go to sensors, and there you can store your information about your sensors directly in the so-called sensor database. You see here my sensor database, which includes the most important current transducers, which we are frequently using, and also some sensors from a personal demo pool. For example, you see some microphones here and also some acceleration sensors. And now you can see that you can not only store the name, the serial number, and the scaling information, including the physical engineering unit of the sensor, but also the entire channel scaling and the entire amplifier setup can be stored to the sensor database. So you can say, okay, this sensor needs an IEPE input with the input range of 0.3 volt and an excitation of 4 milliamps, and the low pass filter shall be set to auto, for example. All this can be defined and set up here in the sensor database. To add a sensor to this database, just press the Add Sensor button, or it is also possible to edit and to set up the sensor database in an external XML editor, as this sensor database is based on an XML file. And this is also the following advantage, that in case you have several measurement systems and you need to use the same sensor database in several measurement systems, you just have to create the sensor database once, and then you just copy the XML file to the different measurement system, and there you can use directly the sensor database as well. So this is the database where the information is stored, and when you want to apply these settings to a channel, just go to the channels menu, and then I'm enabling the first channel of my DACC board. I go to the channel setup, and then you have the possibility to choose the sensor here. I'm now just searching for my microphone with the serial number 2102. There it is. And then when I press the OK button, all the sensor dependent settings are automatically applied to my input amplifier, and that's it. And no further setup of the input channel has to be done, but the settings are automatically applied.
So this is a huge benefit because it reduces the setup time of any kind of measurement quite a lot.
Exactly.
Yeah. Okay, so just a hint again, they're already dropping questions. Please continue like this. We are going to answer them at the end of the webinar. So keep on asking those questions. The next feature is a feature that I like the most. Yeah, what is new for sampling rates? This is amazing.
Yeah, you love the sampling rates, I know.
Oh, yeah.
Yeah, there has also been an improvement. Existing oxygen customers, you know that it was possible to change the sample rate for different Trion modules ever since. So for example, I'm using my Trionet here. I have a multi-board in the first slot, which is running with a sample rate of 10 kilohertz. You see that here. And in my second slot, I have a DACC board. At the moment, it's also running and sampling with 10 kilohertz, but it was ever since possible, for example, to change the sample rate of the second board, for example, to 50 kilohertz. This was possible ever since, and now since the last release of Oxygen 5.2, it is possible to set or to apply a channel-dependent sample rate to each input channel. So this is the so-called channel-wise sample rate selection. And now I'm just going again to the sample rate menu, and I am enabling now here the so-called enable reduction option. And now I have the possibility to set up a channel specific sample rate, for example, let's say of 1 kilohertz here. And now the first channel is still sampled with 50 kilohertz and the second channel is sampled with 1 kilohertz. I could also enable a third channel, say, okay, again, enable the reduction. And now the sample rate of this channel shall only be 50 hertz, for example. And this is now a possibility to set up channel dependent sample rates and not only board dependent sample rates to each channel. And this feature is available for analog input channels and also for math formulas.
That's a huge improvement for our multi-module, making it really a multi-module because, for example, just an example, if you measure temperature, you measure it usually with 10 hertz, not more, and you can now measure with the same module a 20 kilohertz vibration, for example.
Exactly, and the second channel with the temperature is just sampled with 10 hertz, for example. That is possible now.
That's really awesome now, yeah. So we have always also been able to analyze measurements during recording, but we went a step further now.
Yes, correctly. So I think you're meaning the deja vu functionality, which allows you to review your data file you're currently recording during the time. This was possible ever since. And now you have the second possibility to already analyze different data files while the measurement is still running, and also to compare different measurement files, even in case the measurement is still running. I have now my recording instance here of oxygen, and I'm now pressing the recording button. The disadvantage typically was that you were limited to one oxygen instance. So when you try to open another data file, the annoying hint oxygen is already on your system was displayed all the time. Ivica, you know this one, I guess.
Yes.
Yes,
Oh, yeah.
and this this limitation was removed now, and I can now open another data file, for example, here, this one, and I'm just open now in the back the so-called oxygen viewer. It just takes a moment because my internet connection is not that fast at the moment.
So you're opening it from the network?
Yes, and
Network
it's
share?
just
Okay.
opening on a different screen. Sorry, I will show it you in a moment.
Okay.
It's just opening on my right screen. So here we are. Come on. Thank you. So, and now it's really just taking a couple of time. I'm sorry. Here we are now. And now I am able to open several oxygen instances in parallel. Even while one measurement instance is still recording the data, I can start to analyze the data files here with this instance of oxygen. The number of instances is more or less limited. And I have also, in theory now, the possibility to start the data export of my already recorded data of another data file while the recording itself is still running with the so-called oxygen viewer instance. This viewer mode is automatically installed when you install the normal oxygen. So there's no separate installer required for this oxygen viewer mode, which you see here. Yes.
Perfect. Yes, of course, I know this feature because it's a feature that I brought to you from one of my customers. So of course I remember that feature.
Good for you.
Yeah. Yeah, let's continue. So these were like overall usability upgrades to our
Yeah.
software. And I would like to talk now about features and applications within Oxygen. And the big one is order analysis.
Right. I'm just opening a data file in the meantime to show you the capabilities of the order analysis option. So in general, you are now able to do an order analysis with Oxygen. Basically, what does this order analysis option do? On the one hand, you get the frequency matrix, which you see here on the upper left side. So you have the frequency on the x-axis and the rotational speed on the rotational speed of your device on the test on the y-axis. And now you can clearly see here in the frequency spectrum your orders, which are increasing with while the run-up when the rotational speed is also increasing. On the other hand, on the upper right-hand side, you also get an order spectrum with the orders on the x-axis and with the rotational speed on the y-axis. And again, on the z-axis in the color-coded, you see the intensity of the single orders. The maximum or minimum running speed can be adjusted and edited by the user, and also the order resolution can be edited by the user. Additionally, you have the possibility to extract single orders into the time domain. Like you see it here, for example, you have the amplitude of the first, second, and third order extracted in time domain. So this option enables you to extract the order in time domain, to extract the order in time domain, and to plot your order in the dependency of the running speed, for example, but also just in the dependency of the time. And there you see, for example, at which running speed a certain order was very high and where a damping needs to be applied, for example. So this order analysis can also be used during an electrical power analysis. So just think of the run-up of an electrical machine. You can not only analyze the electrical power during this run-up of the device on the test, and parallel, you can also do a mechanical order analysis to analyze the vibration and the sound, for example, of the machine.
Perfect, perfect. And since you are talking about machines and electrical power analysis, we added a pretty nice feature to our electric power group.
Exactly. I think you're talking about the mechanical power analysis, I guess.
I think so too, yes.
Yeah, okay, good. Now I know what you mean. Let me just open another data file to show you the possibilities in the meantime. The mechanical power analysis and the calculation of the mechanical power of a machine was possible since the last release, until the last release via math formulas. Just take the signal of your rotational speed sensor and the signal of your torque sensor, multiply both, and then multiply them again with 2 pi, and that's the mechanical power of your device on the test. The disadvantage hereby was that the mechanical power was updated with the sample rate of your sensor. So typically it was updated several thousand times per second, because speed and torque are typically sampled with kilohertz sampling rates. The advantage for this mechanical power analysis feature is now that you don't have to manually apply the calculation anymore. You just add and drag and drop the rotational speed signal and the torque signal to your power group, and then the calculation is done automatically. And the big advantage hereby is that your mechanical power values are output with the same sampling rate synchronized to your electrical power data. So they are also updated for every period of the fundamental frequency of your electrical system. For example, when your fundamental frequency of your device on the test is 50 Hertz, you will get a new mechanical power value every 20 milliseconds. And so the electrical power data and the mechanical power data are synchronized. And this feature outputs the mechanical power on the one hand. In addition, it outputs the mechanical speed synchronized to your fundamental frequency, the torque synchronized to your fundamental frequency, and also the mechanical efficiency of your device on the test.
Perfect. Perfect.
Yes.
Yeah, so a perfect addition also to our power group is our efficiency map, which is not only an efficiency map, I guess.
Right. So one feature was implemented in the next release, which is called matrix sampler. This matrix sampler could be used to plot an efficiency map during the measurement. This is a synthetic example of an efficiency map. So on the x-axis, the rotational speed is plotted here, and the y-axis shows the torque of your device on the test. And color-coded on the z-axis, you see the efficiency here. So this map will show you the efficiency of your device on the test in the dependency of different load steps, color-coded here in the z domain. This is a so-called efficiency map. So this map is calculated and updated online. Many of our competitors in this area are only able to do this analysis offline, but we are already able to use this feature online and to visualize this information online while the measurement is still running. And Ivica, as you already correctly said, this efficiency map is not only an efficiency map, but much more, because as I said, there's the the feature behind that is a so-called matrix sampler. So you don't necessarily have to plot the speed on the x-axis, but the axis can be freely defined with any signal you acquired. And for example, you could also plot the speed on the x-axis and as well the torque on the y-axis, but instead of visualizing the efficiency, you could visualize here the emitted sound pressure level of your device on the test or the vibration of your device on the test. And so you could see if the vibration is very high during a certain load step, for example. Something like this could be visualized and analyzed with this feature as well.
Perfect. Perfect. So this metric sampler is adding a huge benefit. And I want to point out again, we can do it online during the measurement. So you can see the plot and the efficiency map or matrix sampler online during the measurement. That's very nice. In combination with all of those new tools, we added the possibility to handle arrays within Oxygen.
Yes, so a brief introduction to the term of array. What is an array? Array are special data types in Oxygen, and I'm just loading a measurement file, a setup file to show you what can be done with this feature. For example, when we're again talking about the electrical power analysis, the harmonics are stored in so-called array channels. So you might imagine that this is just a simple vector where every column, where every cell has a new information. This is called array channel in Oxygen. And with this array math in the formula setup, I have the possibility to extract single values from certain cells of this array and to plot them in time domain, for example. I prepared a small example here. So you see the second order of my voltage channel here, which is constantly banding. And now you can extract this harmonical order, the second harmonical order, for example, in time domain, and visualize the time-dependent trend of the harmonic here, for example, in a recorder. So this could be done on the one hand side with this array math, and on the second side, you can also use this array math to extract single frequency bins from spectral analysis and from an FFT. Again, I'm using my tuning fork here with the strain gauge sensor. You have the measurement signal in time domain available here. I will just change the color a little bit that you see it a bit better. So here is my measurement signal. And down here, you see the FFT, the spectral analysis of my signal. And when I'm smashing the tuning fork, you see the 440 Hertz bin. And you can now use the array math to extract this frequency bin into the time domain and to visualize it like you see it here in the recorder in the middle. And you can now also use an FFT trigger here to start the measurement automatically when this 440 Hertz frequency bin exceeds the amplitude of -40, for example. I will show you this quickly. So I am arming the measurement, and now the trigger is waiting for until the recording event is activated. I'm smashing the tuning fork again, and here you see my frequency bin of 440 Hertz exceeded -40, and the measurement is now automatically started, and the trigger is surveyed on a certain frequency bin in the frequency domain.
Perfect, perfect. And since you're already holding the fork, I know this is one of your favorite parts, so let's talk about sound measurement.
Yeah. But a tuning fork does not necessarily include sound level determination as well, but yeah.
Okay.
It was a good one either. No, no worries.
I tried.
Yeah, since oxygen 5.2, we have also a sound level option available. I will just quickly load a data file to show you the most important capabilities of this feature. There we are. Come on. So the sound level option allows you on the one hand to determine the time-dependent, frequency-weighted and time-weighted sound pressure level of a microphone signal, for example, here. I'm just holding it now in the camera. You see a microphone here. And on the upper recorder, you see the time-dependent trend of your sound pressure level, which is frequency-weighted on the one hand. So you can weight the signal with ABCD frequency weighting, and you can also apply a time weighting, fast, slow, or impulse on this channel, which are defined in the sound pressure level dependent relevant standards. On the other hand, the LAEQ, the energy equivalent sound pressure level, is calculated. The minimum and maximum occurring sound pressure level during the measurement will be determined and automatically calculated. And you also have the possibility for a time-dependent sound pressure log. So you can update the minimum, the maximum, and the average sound pressure level for a time interval, for example, of 1 second, like you can see it here. And additionally, I would like to show you that you can also determine the frequency-weighted raw sound pressure still in Pascal, which can then be used for an order analysis in case you don't necessarily want to perform and to determine an order analysis for the structure-borne noise, which is acquired by an accelerometer. But you could also use this channel to calculate airborne sound or an airborne order analysis by using the signal of a microphone, for example. That's just the very brief and quick introduction into this feature. If you have specific questions for this feature, please feel free to ask us afterwards in the chat, or also just write us a short email when you have some specific questions about the capabilities and possibilities of this feature.
Yeah, it's a huge new feature, with a lot of options and possibilities, definitely. So
Exactly.
we talked now about sound measurements, electric and mechanical power measurements, speed, order analysis, and all of them are somehow needed for automotive tests and measurements. Are there any further features, news regarding automotive that I did not mention, or that we did not mention so far?
Yeah, we didn't mention any automotive features so far yet.
Okay.
There are some news. There are some news, yes. On the one hand, we are now supporting the Vector VN series, the VN hardware series from Vector, to acquire FlexRay and CanFD data streams in Oxygen. So the VN series has data interfaces for automotive buses, which are connected via USB to your measurement device, and you can use the adapters of the VN series to acquire and decode CanFD and also FlexRay data streams in Oxygen, and to synchronize them to your analog data if it is required.
Okay. Okay. And since we talk about digital information and buses, we have a new decoding feature.
Yes, a new decoding feature for automotive buses. So a new decoding feature for CanFD and FlexRay. In the past, or let me start like this, when you acquire for example, CAN data streams or automotive bus data streams during the measurement, you don't necessarily know during the measurement which channel is important to you for the analysis. So you don't necessarily know which messages and which channels need to be decoded during the measurement. The disadvantage of Oxygen was that you cannot decode the channels offline when the measurement is finished. And to be sure that no information was missing, you didn't know in advance which channels are important to you, you had to decode all the channels while the measurement was running. And as there are typically some 100 channels in arriving from the CAN bus, the channel decoding during the measurement is very requires a very high CPU load. And we have now added the possibility and the functionality to also decode the channels from the CAN and the CAN-FD and the FlexRay data stream offline during the data analysis. I will quickly show you how this is working. So you see here the raw CAN messages, which are arriving from a temperature measurement module, which is here on my desk. And I will now go to the channel list and open my CAN channel here. And then I can now load the DBC file for my temperature module. And now this so-called channel picker dialog will open. And there you can directly say, okay, I only want to decode some channels or some messages. And to show you this feature now, I will only decode channel 0, temperature channel 0 during the measurement. So I just select it here and press the OK button. And then this channel and only this channel will be decoded and added to the channel list. During the measurement, I can now visualize this data with a recorder, for example, place it here on the screen. And I'm now applying the signal here from channel 0. Just change the color a little bit and also change the scaling. And now only this channel is decoded during the measurement. So I'm now starting the measurement for a couple of seconds. The raw CAN message or the raw CAN data stream will be decoded and will be stored, but only this channel here will be decoded and no other channel here. And after stopping the measurement, I can now open the data file, which is this one. And now I can still decode other channels during the data analysis if this is required. Just go again to the channel list, go to your CAN channel again, reload the same DBC file, and there you see, okay, channel 0 was already decoded, and now you can select any other channel for decoding it offline. And that's the new feature, the new so-called offline decoding possibility for CAN channels or for CAN messages, for CAN-FD messages, and also for FlexRay data buses. Just press OK, and then the channel is added here to the channel list and decoded automatically. And then you can also visualize it here on the measurement screen with the other channel, which was already decoded while the measurement was running. That's the so-called offline decoding of CAN, CAN-FD, and FlexRay messages.
Perfect, perfect. So this helps so much because you don't lose any data anymore on the CAN bus, and it allows you to just lock the CAN bus. And if you think that there might be information somewhere that you did not decode, you can decode it afterwards and synchronously to your measurement.
Exactly.
Which is awesome.
And the data size of your data file will be significantly reduced as you can only store the raw CAN data stream, and also the CPU load for decoding the CAN message will be significantly reduced. So the CPU load will be much lower during the measurement.
Perfect. That's nice to hear. And I was checking the release notes again because I miss a feature, and that's the ABA storing. It's not in the release notes anymore, Raphael. I just realized it now.
Yeah, that's just a different wording now.
Oh, okay.
The ABA storing was our internal working name, more or less, for this feature. But it was this feature is released under a different name.
Okay.
I will show it quickly to you now. You will find this feature in the trigger and recording settings, and this feature is now called individual channel configuration.
Makes sense.
You will
Okay.
find it here.
Okay.
I will not explain you this feature in detail, but just give you two examples for what you can use this feature.
Perfect.
On the one hand, you can use this feature to store channels at the full sample rate, no matter if a triggering event is at the moment active or not. So ever since the limitation was there, or the possibility was there to have a triggered recording and to only store the measurement data of all channels when the trigger event is active, and to not store it when the trigger is not there. And now this feature enables you to exclude some specific channels from this trigger event and to store them anyway at full sample rate all the time, no matter if a trigger is active or not. And on the other hand, you can use this feature to store certain channels at sample rate A when the trigger is not active, and at sample rate B when the trigger is active. And that's why this feature was internally called ABA storing, from channel rate A, from sample rate A to sample rate B back to sample rate A. And now this feature is just has just been released under the name individual channel configuration.
Okay. I would just like to sum it up and bring, I think, one more example.
Yeah.
So we are now able to continuously record any calculated power values like any other power analyzer in this world. But additionally, on a given trigger, we are now able to record raw data of all the signals if necessary, or of a sum of the signals. It doesn't matter which one, because you can choose now what the trigger should do with any kind of raw data signals.
Exactly. So you always had the possibility to store the raw data continuously. And now you can also say, okay, there is a trigger, a certain event when my raw data really interests me or not. I want to store the raw data there, and otherwise not. But in addition to exclude the calculated power values from this trigger and to store the power values all the time continuously, and only the raw data on a certain event or not.
Perfect. Perfect. Reduces your measurement data file by a huge amount as well.
Exactly.
If you record the data, the raw data only if it is necessary.
Exactly.
Okay. So also, again, the reminder, questions are dropping. We are going to answer them all at the end of the webinar. Just keep on asking. We have already 1, 2, 3, 4 questions. So just let's go over to the next point, and that's the Oxygen SDK. What is it and what does it do?
Oxygen SDK, the SDK is the abbreviation for Software Development Kit. That's a possibility and an option to expand your Oxygen exactly customized to your needs. When you need a certain calculation which is not directly implemented and available in the math section of Oxygen, for example, you can use this SDK to program and to develop your customized calculation and to have it available in Oxygen, for example. On the other hand, you could use this option and this possibility to write your own user-specific data export plugin, for example. You have a very specific, very rare export you just require, and you don't necessarily want to share the information with us and the information how the data is exported in detail. So you can write your export plugin by your own. On the other hand, you could say, okay, you have a specific sensor, for example, which provides the data over a serial interface, and you could also use this plugin to read the data from the certain sensor with Oxygen. So this is, yeah, more or less, this is a programming interface, a customizable programming interface. So C++ knowledge is required here because the software development kit is based on C++. And more or less, this is an interface for you to enhance the Oxygen by your user-specific and customized needs. And all the information, yeah, sorry.
No, you're okay.
And information and documentation is available on the in the internet on the page called github.com.
Okay. So to summarize it, customers are now able to implement theoretically everything within Oxygen with a self-made plugin.
Theoretically, yes.
Okay.
And in the practical way, we are still working on this and the functionality is still enhanced. But in
That's
the
our goal.
hopefully near future, you could do more or less everything which you require in Oxygen and implement your own plugins in Oxygen, yes.
Perfect, perfect. Our last point now, Raphael, for today before starting to answer those questions. Can you and are you allowed to tell us something about the next release and what features are planned?
So I'm not really sure if I'm allowed to, but I will do it anyway.
Okay.
So if I won't be there on Thursday for the next webinar, you know what will have happened.
Yes, okay, perfect. Okay.
Yeah, currently for the next release, which will be end of September, we are working on the so-called CPB spectrum. So on a constant percentage bandwidth visualization of your data in the frequency domain. Additionally, to enhance the functionality of the sound level option a little bit more, we will also add a wave export and a audio replay functionality during the data acquisition and during the replay, that you are able to replay some data channels by your sound card and to listen to them. We are working on a Modbus plugin to acquire Modbus data which are coming in via TCP. We are working on an RPC3 export plugin.
Oh, nice.
And
Okay.
for our aerospace customers, we are working on acquiring and decoding A-Ring data with Oxygen by using AltaDT hardware. That's more or less
Okay.
everything I know at the moment from our R&D.
Thank you
referring to
for those
Oxygen.
insights. Thank you very much for those insights. I would start to answer the questions, or I would start to read those questions to you, and hopefully you can answer them.
Okay.
Question number one is, in automatic recording mode, so it was the automatic recording mode, does Oxygen take into account that the initialization delay of I guess, a third-party hardware on power on to ensure that Oxygen is able to detect and initialize this hardware properly?
Yes, this is done during the startup of Oxygen. It scans for all available hardware, and after Oxygen has checked all the interfaces and seen and realized which hardware is really connected, only afterwards the recording is started and not before.
Perfect, perfect. So just to add something to this, so you are able to arm also the system and start the measurement with a trigger in case there is anything different, maybe that has to be initialized, which is a third party, whatever.
Exactly, this is also possible. So more or less this auto recording option does avoid that the user has to press the record button or the arm button manually to store and to start the recording of the data.
Okay. Second question would be, very interesting question, will there be any automatic detection of sensor, TATs? TATs is always a question that we get.
This is currently under surveillance. Nothing is planned yet, but that's also something I am foreseeing since a pretty long time, that the TATs recognition is also implemented in Oxygen. So we are currently checking that, but it's not scheduled yet.
Okay. As soon as we get any news on this one, we are going to let our audience and customers, of course, know, definitely.
But it's in our backlog.
Yeah. Or regarding the sensor database, that's a really interesting question. I'm not even sure if it's possible, so I'm going to ask you, is it possible to send data from an already set channel? So a set channel for any kind of sensor, and can you, when you set up that channel, put this information into the sensor database. Example given, user usually needs to set the input channel to get any kind of information. And when he does those settings within our channel menu, is it possible to take those information and those settings and put them into the database, into the sensor database?
And not yet. At the moment, it's only possible to apply the settings from the sensor database to a channel, but it's not possible yet to export the channel settings into the sensor database, unfortunately. But it's also on our backlog.
Okay. I'll write you a customer request for this one after this setting. So
yes, please.
Very, very nice idea, and I really like it. So yeah, we're going to talk about this one. There is one more question, and this is so far the last question that I see here. Could you please expand on the alarm feature and the event page, and what do I need to make it work? So if you could show alarms within the trigger event page, I guess that should answer that question. Yeah.
Yes. So basically, what do you need to enable? You need a condition when you want to set the alarm. For example, if my microphone exceeds the threshold of 1, the alarm shall be activated. And that's the condition type when the alarm event shall be activated or not. And then you go here to the action. You have to define the alarm action. And for sure, you also need some digital output channels here. At the moment, I unfortunately don't have a digital output channel available here, but then you select the digital out channel and you say, okay, when the alarm is activated, the output shall be set to high or to low, and optionally also automatically reset after a certain instant of time. And that's it more or less. And further features, further explanations can also be found in the Oxygen manual. If you have a specific question about this one, please just don't hesitate to write me an email. Then we can directly answer that.
Perfect. Perfect. Good. That's so far. I don't see any further questions here. So thank you everybody for listening. If you have any further questions, feel free to contact me and my colleagues directly, or write us an email or call us. Our contact data is available on our homepage where you registered, or on social media, of course. If you know any colleagues or people who would be interested in this special webinar, me and Rafa are going to do the same session again on Thursday morning this week. And at the end of this week, we are going to put this webinar, or the webinar from Thursday, on YouTube, available for everybody. So this is it from our side. Thank you for watching, and see you next time. Bye-bye.
Thank you. Bye-bye.